Continuing with example 8, this method works well if you have complex fractions. We take whatever's in the denominator and we multiply that to both the big numerator and the denominator. And so when I say denominator, I mean the smallest denominator you have as part of the complex fraction. So in this case, we would multiply by 2 times 2 plus x and 2 times 2 plus x because that's just 1. So we're just multiplying by 1. And if you do that, we're going to get limit as x approaches 0. Don't forget to bring that down. 2 minus 2 plus x over x times 2, I'll put that in the front, times 2 plus x. Distribute that out, and you'll get 2 minus x. Don't forget to make it a negative x. So we have the limit as x approaches 0 of 2x times 2 plus x. Now the x's will cancel, so we end up with negative 1 over 2 times 2 plus x. Plug in your 0 here, and we get negative 1/4. Now we couldn't just try to direct substitution because we get 0 over 0, and we know that's a problem. Okay, similarly here, we're going to multiply by 6 times x minus 6. 6 times x minus 6. To get the limit as x approaches 0, 6x minus, or times the quantity x minus 6, all over. That would be x minus 6 plus 6. So that ends up being, those cancel out, the x's cancel out, plug in your 0, you get negative 36. So that's a good way if you have your least common multiple over least common multiple. The sledgehammer method, that requires a small line for me. You just expand it out, get rid of stuff that cancels, and then plug it in. So we have limit as h approaches 0. X squared plus 2xh plus h squared minus x squared all over h. X squared minus x squared, they're gone. Factor an h out of the numerator. And so then we'll be left with limit as h approaches 0 of 2x plus h. Okay, if you factor the h out of the numerator, cancel it with the 1 in the denominator. Now plug in 0 for h, and you're left with 2x. The next one's going to require a lot of space. I'm going to try to write tiny. Limit as h approaches 0, x squared plus 2xh plus h squared minus 2x minus 2h plus 1 minus x squared plus 2x minus 1. I bet a lot of things cancel. I'll do a different color. X squared gone. 2x gone. 1 gone. Oh look, there's an h and everything left over. Let me go back to my tiny blue pen. So if we factor out an h and then cancel it out with the 1 on the bottom, we're going to take the limit as h approaches 0 for 2x plus h minus 2. So let h be 0, you get 2x minus 2. And then that's something we could do. It just takes a little bit of space. Okay, this is that great graph. Okay, if you remember, it looks like this. Or maybe you don't remember, and now you know. Okay, absolute value of x over x, or the reciprocal of that. It's just either going to be negative 1 or 1. That's it. Okay, if you want to break it down into a piecewise function, if that makes you feel better, it's 1 if x is greater than 0. It's negative 1 if x is less than 0. Notice I didn't put or equal to. Okay, I'll draw a bigger graph. It's negative 1 on this side and positive 1 on this side. It's not 0 because then you have 0 over 0, and we know that's a problem. So this is a jump. Senior salta, and salta means jumps. Okay. So the limit as x approaches 0 from the left. Look on the left side. Oh, it's going towards negative 1. On the right side, it's positive 1. as x approaches 0 does not exist because the left side doesn't equal the right side. And now as x approaches 3, well, that's going to be somewhere over here. So it's just 1. Not too bad. Okay, we're going to use that same idea, that same graph, just transformed a little bit. Let's see, let's write it this way. If I factor out a 2, I have x minus 5 over x minus 5. Now that part, just that part, let me draw. Remember, that's either 1 or negative 1, depending on what side of 5, in this case, we're on. So we want 5 from the left side. So that's going to be negative 1. So we have 2 times negative 1, or just negative 2. Okay, this is the same graph, same idea, same function as this. But this time we're looking at the right side of 5. And if you go on the right side of 5, it's going to be positive 1. So 2 times positive 1 gives you 2. This one says 5, and that implies from the left and from the right. So that would be 2 or negative 2, but it does not exist because it can't be both of those numbers at the same time. If you try these examples or separate them into one of those functions where it's the same thing over top of the other one as long as one has an absolute value, you'll see that it's not so bad. It looks scary and intimidating. You try direct substitution. And let's see, on the top you have 9 times 0. I can't think right now. Let's just do it this way. Limit as x approaches negative 3 from the left. So I'm going to separate out a few things. I'm going to write my x squared here. Let's make it 2x squared. Then we have x plus 3. I'm going to put my 4 here. And then I have x plus 3. Okay, so if I just evaluate this part, negative 3 from the left side gives me negative 1. Okay, 2 over 4, well, that's just put a 2 down there. All right. So we have negative 3 squared, that's 9. 9 over 2 times negative 1. This next one involves a little bit of factoring, but you guys are really good at factoring, so it doesn't matter. So we'll factor that into x minus 2. I meant minus 6. There we go. Over, and let's take the 2. X minus 6. So again, we have this part. We're evaluating at 6 from the right side. So as x approaches 6 from the right side, that gives us positive 1. Now we just plug in the 6, use direct substitution in the other part. So we have 4 over 2, or just 2. And that, remember, was positive. Oh, this one looks scary, but it's not, as long as you factor it in a nice way. We have limit as x approaches 7. We have sine of x. Let's pull that 3 out. And we have x minus 7 inside the absolute value. Then we have x plus 7, x minus 7. Okay, remember we have that part. We're evaluating this as x approaches 7 from both sides. We know that's a problem here. So to answer that one, does not exist. All right, and then this last part on this page, example 13, with a calculator, evaluate the following and memorize the results. Okay, so this is something I want you to write the answer for these two. Just put A and B in your whisk. But we're going to try to talk about these ones in class. Think about how these functions are transformed when you put, for example, a coefficient, or that's another coefficient, or if you move it to the left or right. All right, go ahead and put A and B in your whisk.